This would have been the device used for the SDC if COVID-19 didn't occur. Carlos, our SOLIDWORKS expert, is here to show you how the device would have functioned at the competition. As you can see, he is showing how the device would have looked entirely, with the motor and bevel gear below, to the crimping actuator above, Paper 1 will fall into the loading bin found at the top due to gravity. Actuator A will actuate to the paper. Actuator A will then take the paper to the mold and, due to its arm, fold the paper around its edge. Actuator B will actuate out to the mold and fold the paper. Actuator C will begin the process of folding the paper. However, due to Actuator B being in the way and problems will arise, it will have to retract out of the way. Once Actuator B is out of the way, Actuator C will finish folding the paper. Once all three actuators have folded the paper, they will retract to their starting positions. Through the bevel gears, the lifting component will lift the paper. This lifting component will lift the paper until the wheels have a solid grip on the paper. Then, the lifting component will retract to its starting position. The wheels will roll and slide the paper along the way until the bottom of the paper reaches the slit found at the top of the mold. There it will rest until the second paper will reach the mold. Paper 2 will fall into the loading bin just like paper 1. Actuator A will again take the paper and fold it around its edge. Actuator B will fold it around its edge just like the previous paper. C will also fold the paper just like it did for the first page. However, the actuator B will still have to get out of the way due to complications that could arise. All the actuators will retract once their job is done. The lifting component will lift the paper up until the wheels have a firm grip on it. However, due to the two pages needing to join, the crimping action will occur at 50% overlap. Once the crimping is done, the wheels will spin until the new paper reaches the lip where the paper will rest on for structural integrity. While that was going on, the lifting component will retract to its starting position. Below you can see where the lifting component will rest out of the way of the wheel that the mold rests on. We created the wheel due to the structural integrity of having the center of mass on one side, and the tower will fall due to the mass not being in its true center.